All right, our final goal in this series of videos is to build something that we can use to tune a volt per octave voltage controlled oscillator in the next series of lectures when we start building VCOs. Those VCOs are shown, here's the diagram of the first one we're going to build, and this is one I developed just for teaching purposes based on some very common designs out there. And it's got an input impedance of about 1 mega ohm. This is the voltage control signal comes in here. The output comes out over here. And there'll be some potentiometers which adjust the frequency and the tuning range. So this is what we're looking at for our first VCO is a 1 mega ohm input. And after I show you that, we're going to be doing another one, which is about a 1 mega ohm input or more, and that's the Thomas Henry 555 VCO. And the input for volt per octave, main input will come in here, go through 100K within a 1 mega ohm resistor on its way to some other component. So it's again got about a 1 mega ohm input resistance. This is the input of the VCO, and this is what we're going to be feeding from other devices, eventually a sequencer, for instance, or the MIDI to CV out of a keyboard is going to come in here, and it's just going to see a load resistance of approximately 1 mega ohm. So how do we do this with the information we've learned? Well, one idea would be to try to keep the resistance, the Thevenin resistance, at least about 2 orders of magnitude smaller than this, so that this large mega ohm resistor provides a negligible load or negligible drop in the voltage coming from our calibration circuit. And so I designed this little circuit. That's pretty clear where it comes from. It's got 3 outputs. It's going to have a 0 volt when this push button is closed, 1 volt when this push button is closed, or 2 volts when this push button is closed, and the outputs all go out here. And so you have a Thevenin voltage of 0, 1, or 2 volts, depending on which of these push buttons are closed one at a time. And you can calculate, and this is using equation 14 from the earlier set of this set of lectures, what the Thevenin resistance would be. Now for the 1 volt and 2 volt cases, that's pretty clear process at this point. You imagine shorting the circuiting the output to ground, and then divide that by the Thevenin voltage. For this last one, 0 volts, you'll notice I've added a 10K resistor, and that's for protection purposes. That's the idea is that this is going to prevent someone from shorting out the power supply if they accidentally press the lower button and another button at the same time. So when you think about that, if we push the top 2 push buttons down, current will just divert, go through the 5K to ground, no problem. But if we have this one down and then we also push one of these top ones, current will flow instead of directly to ground through this 10K. And so you see with that 10K choice, it means that the Thevenin resistance of all 3 is kind of in this 10K region. And again, that is much smaller by about 2 orders of magnitude than a mega ohm. So it's a good start. We also have the parts to do this. You'll need a breadboard. You will need a couple of push buttons from Physics 110 class or that kit. Any type of push button. I happen to have these 4-legged push buttons here, and just as a reminder, you have to check and see which are connected. Turns out the 2 on the same side of the bar are always connected, and the push button activates across the bar, but you need to check your buttons with a multimeter to see that that's the case. And then you need a couple resistors, of course, a 5K, 5K, and a 50K. And as I mentioned earlier, it's not a real good idea to use fixed value resistors, which only are good to within, say, 5%, if you are going to try to have very accurate voltages on the output. What you need to do is use potentiometers instead. Well, that's no problem. And that's why I've chosen the 2 5Ks here, is that there should be a large 10K pot in your extras bag with the X on it, I believe. And I think there also will be a 500K pot, which was in your extras bag as well. We'll use this 10K pot here with the bottom on ground and the top then connected to just one pin. Open this up now. Just one pin. We'll only use center pin and one pin to get 50K, or about 1/10 of the way through this 500K pot's range. So that and a breadboard and a 10K resistor. Should have plenty of extras of those laying around, and some wire. And then to make it easy to set up, we're going to use the same power supply as our URAC power supply. So by now you should have a nice functioning plus minus 12 and ground available, and you can just use this, put an IDC connector on the end of one of those, and then we're going to make a useful device. Now you have to solder this, and this is something we use many times in the rest of the quarter, where you can just plug in your power supply to make sure it's keyed correctly, and then it can be plugged into your breadboard like this. That's the idea. So let's see a little bit how this is done. I take a couple of headers. Those will be in the asterisk bag. There'll be some headers. Of course, the board will be in the asterisk bag. And I'm going to solder those in so that they mate with the breadboard. It can be a little tricky to get them in there solidly. You probably want to stick these in the breadboard first and then solder. And this is a matter of doing the connections. You have a plus 12, a minus 12 and a plus 12 and a red and a blue. And then the black are the grounds, those are in the middle. And so you can just do a little solder bridging across these. The only reason I use 3 or 4, I guess in this case 4 header columns, is for mechanical stability, so that when it goes into this breadboard, it really fits in there well. So that is a really useful device, and we'll use that for prototyping circuits that will go on our breadboard before we actually design them. And I can give you a couple close-ups here. Not the greatest soldering job, but again, I'm just using this cheap perf board, which you should have plenty of extra of that. And wire again all those ground pins. I go to the ground side, and I'll put those on the inner rails of my breadboard, and then a minus in red and the plus 12 in blue upwood on the outsides of my breadboard. And so this will be the minus 12 rail and the plus 12 rail, and the grounds in the middle. And that'll allow me just to build the circuit like that. Remember to get the notch in the correct orientation, and always check your voltages with your voltmeter before you power anything up, and make sure it's correct.